The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave your video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so in this session, we're going to take a look at section 8.9, and our topic is variation. And there are three kinds of variation we're going to look at today. The first one is called direct variation. Okay, and it is generally in the form y equals k times x. Now, k has several different names, but all meaning the same thing. It's called the variation constant. Sometimes it's called the constant of variation. Sometimes it's called the constant of proportionality. I just call it the variation constant because that's the shortest name. So variation constant. Now, a constant is not a variable, it's a number. So what's going to happen in each of these situations, we're going to have k, the variation constant, in a formula. We're going to be given some information that will allow us to determine what k is. We will then put that number in the place of k and proceed with a follow-up question. All right? Now, the way that direct variation works is that if x increases, y increases. So if x goes up, y goes up. But if x decreases, y also decreases. So x and y go up together or they go down together. They vary directly. So let's take a look at an example of that. Okay. This says free fall. An object in free fall travels a distance s that varies directly to the square of the time t. All right, now I wrote y equals kx as a general description of direct variation, but in this case our variables are s for distance and t for time. Okay, so again it says an object in free fall, so in other words an object that's being dropped, travels a distance s that varies directly to the square of time. So s equals k t squared. Now it didn't mention k, it didn't mention the variation constant, did it? But k is always going to be present in any of these formulas, whether they mention it or not. So the distance varies directly as the square of the time. Okay, so that's where we get our direct variation formula. Now, it says if an object falls 1,024 feet, so that's s, so 1,024 feet in 8 seconds, how far will it fall in 10 seconds? Well, we now know that 1,024 equals k times 8 squared. 8 squared is 64, so we could say, whoops, yes. We could say that 1,024 equals 64k. Now, solving for k, if we divide both sides by 64, k equals, let's see, it's calculator time. 1,024 divided by 64 is 16. So now I know that for this situation, k is 16. So that's going to go right there. So now my formula becomes s equals 16 t squared. So let's review. I read the problem, determined it was direct variation, what my variables were, wrote my formula. Used information given to determine what k was, put that number in for k. Now we're ready for the follow-up. How far will it fall in 10 seconds? So the distance and then 10 squared. Well, let's see, 10 squared is 100. 16 times 100 is 1600 or 1600. And the distance, it said in the problem, object falls 1024 feet in 8 seconds. So the distance is in feet and the time is in seconds. So this would be 1600 feet. And there you have the first problem. Any questions about this example? So again, direct variation, when x increases, y increases. If x decreases, y decreases. Okay. Second example of variation is called inverse. Oops. Inverse variation. There we go. Can't spell this morning or any other time either for that matter. In general, y equals k divided by x. So now we have this reciprocal situation where the variable x is in the denominator. In this case, x and y, well, if x goes down, y goes up. If x goes up, y goes down. Okay, so there's this inverse variation. As one goes up, the other goes down. As one goes down, the other goes up. Okay, inverse variation. Now, let's take a look at the example of this. Let's see. It says organ pipe, so a pipe organ. The frequency of variation of air in an organ pipe is, or I should say, varies direct. Let's try that again. Let's try this one again. The frequency of variation of ore in, I just can't even talk at all. It must be Monday. The frequency of variation, it's not even variation, it's vibration. I can't even talk and I can't read. It's really Monday. Okay, here we go. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. Whew, I made it through. Okay, so what have we got? We've got F is going to be the frequency of vibration, and L is going to be the length of the pipe. Okay, so our two variables are F and L. F is the frequency of vibration, so how many times it vibrates, and L is how long that organ pipe is. All right, again, the frequency of vibration, so that's F, varies inversely. Now, notice K is always on top, inversely to the length of the pipe. Okay, now sometimes instead of using the word variation, it'll say proportionally or proportional. Same idea. Okay, so F varies inversely as L. Okay, if a pipe 2 feet long, so that's what, L, vibrates 256 times, that will allow us, that information will allow us to determine what K is. To solve for K, I'll multiply both sides by 2. K equals what? 512. So now that goes up there. So now our formula becomes F equals 512 divided by L. So again, we went through and read the problem, which took me a while to get it right. We identified what the variables were. We set up our formula, F equals K divided by L. We plugged in given information to determine K. We then replaced K with the 512. Now the follow-up says, how many times per second will a 6-foot pipe vibrate? So what's the frequency of a 6-foot pipe? Now, if we take 512 and divide it by 6, we get 85.3 repeating. Recall that 3 repeating is what? 1/3. So this would be 85 1/3 times. Okay. Any questions about that particular example? So we've got direct variation. One goes up, the other goes up. One goes down, the other goes down. Inverse variation. One goes up, the other goes down. One goes down, the other goes up. Okay. Think about supply and demand. If there's more demand, let's see, how do I want to say this? Oh, if the price goes up, the demand goes down. If the price goes down, the demand goes up, or at least people are more willing to buy it if it's cheaper. So you sell more when it's cheaper, you sell less when it's more expensive. Okay. All right. Anyway, third example is called joint variation. And what that looks like in general is y equals k, and they say xz. Think about a joint checking account. If any of you even have a checking account anymore, it means there's more than one person on that account. Or a joint loan would have like a cosigner. There'd be more than one person on the loan. Okay, so joint variation, you have more than one variable on the right side of the formula. Okay. So let's see here. This says the number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. The variation constant is 23.5. Find the number of gallons that can be stored in the cylindrical tank shown. Okay, notice they finally actually mentioned K and they told us what it is. They said K is one of these days I'll be able to write, I doubt it. K is 23.5. Now, there's a drawing, which I will attempt to reproduce, of this cylindrical tank. Okay, and the picture tells us that the diameter is 15 feet and the height is 20 feet. Interestingly enough, the drawing in the book and my drawing both make it look like its diameter is larger than its height. So don't trust the drawing, just trust the numbers. Okay. Now, so we have a tank that's 20 feet high and has a diameter of 15 feet. We know that the variation constant is 23.5. Let's go back to the original problem again. The number of gallons of oil that can be stored in a cylindrical tank. So how about if we let G equal number of gallons? Okay, I know that looks like hashtag, but it also stands for number. Let's see, the number of gallons stored in a cylindrical tank varies jointly as the height of the tank. So H is going to be the height. And the square of the radius of the base, R, is going to be the radius of base. Okay, now, so what's our formula going to be? It says the number of gallons, G, equals K times, let's see, varies jointly as the height of the tank, H, and the square of the radius, so HR squared. So G equals KHR squared. That's our formula. Now, it says find the number of gallons. So the number of gallons equals 23.5, that's K, times H, which is 20, times R squared. Well, now, be careful. If the diameter of this tank is 15 feet, what would the radius be? Anybody? How do you find the radius if you know the diameter? Nobody wants to try. Okay, the radius is half of the diameter. So let's say we've got a circle and this is the diameter all the way across. So that's the diameter. That's the radius. So the radius is going to be 15 over 2, or how about 7.5? But that's squared. Okay, so G equals 23.5 K times 20, which is H, times 7.5 squared. So we've got to cut the diameter in half. Let's see what we get. 23.5 times 20 times 7.5 times 7.5, and we get 2,647.5 gallons. So 26,437.5 gallons is how much oil that this tank will hold. Any questions about that? All right. So we've got 3 kinds of variation. Direct variation, y equals kx. Inverse variation, y equals k divided by x. And joint variation, y equals kxz. You want to have memorized what these 3 types of variation are, so that if the problem asks you for specifically inverse or joint or direct variation, you know which formula to start with. Okay, now we're going to look at some problems where I'm going to give you a written sentence and then we're going to translate that into symbols. So for instance, this says A varies directly as the square of P. So A equals KP squared, right? Again, notice K wasn't mentioned, but it's always in there. Okay. T varies directly as S. So T equals K S. Okay. Any questions? No? All right. Z varies inversely as the cube of T. So Z equals K over T cubed. All right. C varies jointly as X, Y, and Z. So you'd have C equals K, X, Y, Z. So you can have actually 3 variables over on the right side. Joint variation basically has more than 1 variable on the right side of the equation. Okay. Let's see here. Now, it's possible to have a mixed combo, so to speak, more than 1 type of variation going on at the same time. This says P varies directly as the square of A and inversely as the cube of J. So we've got direct variation and inverse variation going on at the same time. P equals K, see, direct square of A, so KA squared, and inversely, so over J cubed. So P equals KA squared over J cubed. Okay, so you've got direct variation and inverse variation going on. Okay. How about this? We'll go the other direction. Now we've got the formula. We'll write it in words. R equals KT. We would say R varies directly as T. B equals K over H. B varies inversely as H. Okay, how about this one? U equals KRS squared T. So U varies what? Jointly as R, the square of S and T. Okay, one more here. P equals KM over N. P varies directly as M and inversely as N. All right. Any questions about that? Okay. Well, that's all I've got for you today. So if there are no further questions, we'll call it for the day.
Would you be able to go back to the assignment and do on part?
Say that again?
Would you be
I can't hear
able
you.
to go back to 8.4 on the assignment in part 22?
Sure.
Sorry, part 21 on 8.4.
Okay. Yeah. And we can do that. I generally ask for questions at the beginning of class, but maybe you weren't here, and we can certainly do it now. But so 8.4, right?
Yes.
Okay, let me get into WebAssign and take a look at what you're asking about, Yesenia. Okay. Give me just a minute here. Let's see here. You said 8.4?
Yes, on number 21.
Okay, 8.4. Just a minute, I'm getting there. Scrolling down. 21. Okay. So, can you see it now?
Yes.
All right. Solve the compound inequality and write the solution set in interval notation. So we've got -3 less than or equal to 1 minus 5x over 3 less than or equal to 3. Okay, so now I've got that written down on the whiteboard. I'm going to go back there. All right, so I've got 3 pieces here, and anything I do to the middle piece, which is where x is, I have to do to the outside pieces. I want to clear that fraction in the middle, so I'm going to multiply the left side by 3, the middle by 3, and the right side by 3. Okay? Now, That's going to give me -9. Inside, the 3 here and the 3 here are going to reduce down to 1 minus 5x, and then 3 times 3 is 9. Are we okay with that so far?
Yes.
All right. The next thing I'm going to do is subtract 1 from each of the 3 pieces. -10 less than or equal to -5x less than or equal to 8. The next thing I'm going to do is divide each piece by -5. So I get -10 over -5 is 2, and I get x, and I get -8/5. But because I divided by a negative number, I change the direction of both inequality symbols, okay?
Okay.
But now my statement goes from largest to smallest. So I'm going to rewrite this thing going from smallest to largest. So it's going to look like that. So that's my answer. But what would that look like in interval notation? I'd have a bracket, -8/5, comma, 2, and then another bracket, and graphing it on the number line. Let's see, 1, 2, and then 1, 2. So +2, and then -8/5 would be like -1 3/5, which would be about here. Okay, so going back to the WebAssign page, the correct choice would be this one here with a little key by it, -8/5 to 2. You okay with that?
Yes.
And then graphing it down here, getting the part on 2 is easy. Over here, and this is what I kind of warned you about the other day, you kind of have to estimate. So this is what, -1 3/5. So it's not halfway, it's a little bit more than halfway, 3/5, -3/5, excuse me. And then you need to fill in between as well. Okay, you all right with that?
Yes, thank you.
You bet. Any other questions about any previous assignment stuff or more clarification on today's stuff? Okay, well then I will go ahead and stop the recording.